APEC 2024. I'm Martin Rowe with EE World. We're in the Texas Instruments booth, and we have quite a board over here. This is a board used to show power delivery for servers. And Abinay is going to explain some of the components on this board and how and why we get from a power supply down here that's at 12 amps down to get the power that we need, the hundreds of amps to run that CPU. So Abinay, why don't you tell us a little bit about this board?
Yeah, thank you so much. So this is a complete power delivery reference design solution from TI for servers. So as you're saying, we have a 12 volt power supply here at the bottom. The 12 volt power supply comes into the board, and at the board input, the first thing you need is protection, because these boards in a server can be hot swappable. So you need inrush protection, short circuit protection. So all of that is done by this tiny little circuit here, right? These devices are called eFuses, and the devices here, like the latest TPS 25990, is integrated PM bus based eFuse capable of delivering 60 amps in one device, and we can stack multiple of them to get to higher currents. And the TPS 25990 provides over voltage protection, short circuit protection, over temperature protection, and it also gives you a lot of information to help you debug when you have a fault in the system. Okay, so that's the eFuse. From the eFuse, next you bring the 12 volt into the step down DC-DC converter stage. So since this is a very high current requirement, like going up to say 600 or 700 amps for the CPU, so what you need is a multi-phase interlude solution, and this is the latest device, the multi-phase controller, 12-phase controller from TI, along with the integrated power stages, supporting the native TLVR configuration, which has the best efficiency as well as the best transient response, which is needed to support the latest, the CPU, like this one. So this represents like the CPU load profile, what you can emulate. Okay, and apart from that, on the board, you have any other kind of power rail requirements, typically lower currents, say 30 amps or below. So we have a fully integrated the point of load regulators like the one here. Okay, and with this, so you have a complete power delivery in a typical server environment, whether it's an Intel platform or an AMD platform.
So to get from this 12 volts, we're dropping it down and therefore getting more current.
Yeah.
So what kind of voltage do we have at the CPU?
Yep. So this one here, the highest current is on the 1.8 volt rail.
Okay.
Yeah, which goes to the CPU, and that's where you get the maximum current.
Okay. I think some of them go lower voltage and higher current.
Yeah.
I've heard of them. I haven't actually seen them
yet. Yes, absolutely. So you get lower voltages, say maybe 1.05 volts, but you also get other voltage rails like 2.5, 3.3, 5 volts. You get a lot of different rails on the board at different currents, but yeah, the CPU core voltage rail is where you get the highest amount of current, runs into hundreds of amps.
Okay, thank you very much.
Thank you.
For EE World, I'm Martin Rowe. Thank you for watching.